Prima Media's Mining Weekly Online is talking to Craig Hassenjagger, the project manager, AMD. The acid mine drainage has presented some horror pictures in people's minds, but we see quite a well-built structure here to take care of it.
We've used the old RPM mine shaft. We've put a cap on it and we've put 2 submersible pumps in. We decided to go for submersible pumps so that we didn't have to send anybody underground to have a pumping station underground. So basically what we do is we pump the water out. That goes into a splitter box. At the splitter box we add limestone, which then brings the pH up to 5.8. That then goes into the reactor where we mix sludge that comes back from the thickener. We mix with the water. We add lime to bring the pH up to 9, which then causes the metals to fall out. Then you have your clean water coming out the top. We've also got gypsum crystallization taking place in the plant so that it reduces the salts, although it's not enough, and that is why we need the long-term solution to actually clean the water to a potable or industrial standard. The salts aren't out. The long-term solution will actually take out those salts.
How much will have to be invested? How much has been invested so far? How much will still have to be invested?
Currently 2.3 billion, but that is over the 3 basins, the Western, Central and Eastern Basin. And the long-term feasibility study said it would be about 10 billion for the long-term structures in the 3 basins as well.
And what timetable are you putting on the 3 basins and the total solution?
Well, we've first got to do a full EIA. So that can take anything up to from 12 months to 18 months. And then we're looking at possibly 2.5 to 3 years to build the plant.
Is there anything valuable in this AMD that can be sold?
What comes out of the long-term solution, as the second phase, you will get gypsum, which the cement factories are willing to take.
So that could provide a revenue stream which could be offset against the costs. Would
Yes.
that bring the price down?
That would bring the price down.
And will you need more infrastructure for the long term?
At the moment, we will need something like reverse osmosis or desalination plants. Yes, so that part will have to be built still.
And is this going to be replicated in all the basins?
This at the moment is, we've got exactly the same being built in the Eastern Basin. We're busy commissioning this. This plant currently can treat 82 megalitres per day.
You've got the Central being dealt with, you've got the Eastern being dealt with, the Western, what's happening there?
The Western, we upgraded the Rand uranium plant. What the feasibility study that Waterfairs did recommended was that we allocate water there on that side for pilot studies for anybody who thinks they've got a technology that can be useful or cheaper than the current technology. So we would allow pilot studies to take and treat that water. It started in the Western Basin, where with the mines closing down there, they had in 2002 they started having uncontrolled decant, where the water just came out of the ground and went straight into the Tuelopis. It had a pH of 3.5 and it was heavy. It had all the metals and the salts in it. So that was what started the whole problem. And everyone then realized that the other basins were filling up and that they were on their way to decant as well.
That was Craig Hassenjagger, project manager of AMD, talking to Mining Weekly Online.